Hello everyone. My presentation title is Nighttime Lights and County Level Economic Activity in the United States from 2001 to 2019. This study explores how satellite satellite nightlight data can be used to estimate economic activity such as GDP at detailed county level. Yeah. So as you can see the images, this image represents the world map of lights, which is taken from the NASA's Black Marble, shows how nighttime brightness corresponds to human settlement and development. So, coming to research motivation, before research motivation, there are uh, there are two key topics I want to tell. The satellite which was used for this research was Suomi NPP satellite, and the two sensors which were used in this research were DMSP and VWIRS, which is called as VEERS. So the full form of DMSP is Defense Meteorological Satellite Program, whereas for the VEERS is Visible Infrared Imaging Radiometer Suite. So yeah, coming to research motivation. The motivation behind this research is that nighttime lights or NTL data are reliable proxy for measuring economic activity, especially where traditional GDP data are missing or delayed. Older satellites like DMSP provided such data, but they had low spatial resolution and calibration issues. The new VEERS sensor provides more accurate and higher resolution nightlight data, allowing analysis at smaller spatial levels such as counties. But the main question again here is how well can NTL data explain or predict economic activity in US counties over time? We will discuss about it in this presentation. So coming to as you can see, this image shows the differences between the image capture of the DMSP and the VEES and NDUI, and also the technological improvements between the two sensors, and also the scope and also scope between two sensors over the years. And coming to a research objective, so uh, the key objectives of this studies are to use real GDP data for over 3,100 US counties from 2001 to 2019 to compare three major NTL products: DMSP stable lights, Wheels version 1 and Wheels version 2, which is both masked and unmasked, and to evaluate the both cross-sectional and time series predictive power to see how the results vary by spatial scale and industry type. And also the image here explain the flowchart explains the data collection, regression modeling, and comparison of results. These diagrams generally summarizes our process. We combine the NTL data with GDP and apply regression models to measure how well light intensity predicts economic activity. So coming to the data and methods, here we describe the data source and analytical approach. County level GDP data were taken from the US Bureau of Economic Analysis, expressed in 2012 chain dollars. DMSP data were available from 2001 to 2013, whereas WEEDS came from 2014 to 2019. Uh, we used the regression model log GDP is equal to the beta value of log NTL with fixed effects for both county and year. The model estimates elasticity, how much GDP changes when nightlight brightness increases by 1%. And the images show the county level aggregation of nightlight data. So coming to the key findings on the county level, at the county level, the cross-sectional relationship between NTL and GDP is very strong. Using masked Weeds version 2 data, the ask square is about 0.86 and elasticity is around 1.05, which meaning is 10% increase in nightlight brightness corresponding to the roughly a 10.5 increase in GDP. However, the in the time series model, which tracks changes within the same county over time, predicts power is very weak with elasticity around 0.12. Masking uh, noisy or ephemeral lights improves the result significantly, and the image here explains the scatter plot, which is shown explains how strong the positive relationship between night light brightness and GDP. Brighter counties consistently have higher economic output, as you can see. And coming to the key findings, aggregation and industry, when we When we aggregate the data to larger spatial scales, such as state or national level, the predictive relationship weakens. For example, at the state level, the elasticity drops to 0.84, and at the country level, it's almost negligible. This means the finer the spatial data, the stronger the correlation. When we break it down by industries, services show a higher correlation with nightlight intensity than goods producing or agriculture sectors, which is the main reason this research negates the agriculture sector, which is very important. And this chart also shows the service-based economics produce more light at night while agriculture areas remain dark despite their economics activity. So coming to the discussion and implication, from these findings, we can conclude that nightlight data works extremely well for spatial comparisons, that is comparing economic activity between places, but not as well for measuring changes over time in the same place. Despite improvements in the wheat census and making time series predictive power still remains limited. Still, NTL data are very useful in regions where official GDP data are missing or outdated. Research and policymakers can use these datasets to estimate regional economic performance quickly. And here the image shows the global economic geography pattern, and the workflow diagram shows how NTL is processed for the global use. So coming to the limitations and future work, there are several limitations to this approach. First, nightlight data ca- ni- can't capture unlit sectors such as agriculture or certain services. Secondly, the difference in sensor calibration over time passing and atmospheric effects can introduce inconsistencies. Third, the results vary depending upon spatial aggregation. What works well at the county level may not generalize at the national scales. Further research could integrate other data sources like mobile phone activity, daytime imagery, or higher frequency satellite data to improve accuracy. And as you can see, the orbit diagram shows how Weir's overpasses times, explaining how satellite timing affects measurements. Data flow chart shows depicts the integration of new data sources for future analysis. These diagrams generally highlight why sensor timing and calibration matter and how future datasets could fill the existing gaps. So, as per the conclusion, to conclude, V's version 2 mask datasets are most reliable nightlight source for understanding spatial economic patterns at the county level. However, NTL data is still weak indicators of economics changes over time. The key takeaway is that NTL proxies are powerful for spatial comparison but should be used cautiously for temporal analysis. As satellite technology improves, we can expect these datasets to become even more useful for economic policies and researchers. And these are the references I used. I used mainly the research paper, and these other references for used for the images parts mostly. And so thank you.